So in this mod, good morning everyone. In this module, we shall discuss about the different aspects of the design and analysis of deck slab bridge. First of all, what is the purpose of bridge? A bridge is a structure which provides a passage over an obstacle without closing the way beneath. So the required passage may be for a road or a railway or for pedestrians, even for a canal or a pipeline. The obstacle may be a river, a road, a railway or a valley. So the different components of a bridge structure are the basic things. The end you have abutments and in the center if the span is too large we have piers to support the superstructure. And in the superstructure we have the slab, deck slab, the curbs, the approach roads, the handrails, all this forms the superstructure. In the substructure we have the foundations, etc. So for whenever we are planning for a bridge, first we need to collect the data, analyze the data and select what type of bridge is needed. During the data collection, we need to locate the bridge site where the proposed bridge site has to be constructed. And after collecting this site details, we need to find out transportation of bridge site, like how the approach roads are there for the construction materials to be shifted. What is the nature of the crossing and affordability? What are the locally available materials available? What will be the traffic volume that will be used by the bridges? Availability of local building builders or who can construct the bridge. Then temporary crossing or then the local participation by the local people. Those are the preliminary data. Once this data is collected, then there is the analysis of this data part. So based on the data, we have to find out what is the shortest distance of the bridge. So we need to know that from this we can calculate the economical span, the cover depth, vertical clearance and the traffic projections can be analyzed. After analyzing this, we have to find out the shortest distance for the bridge. So to construct the bridge, the first part of the analysis is to decide the shortest route for the bridge from the starting point to the end point and whether it is necessary and economical to construct the bridge. In this part of analysis, curves, ends of river are excluded. So as the distance will decrease between the ends of the bridges and unless otherwise any particular plan is done. So we need to calculate the economical span that depends upon the cost of the substructure and the superstructure. Normally economical span is a span wherein you get the minimalistic cost that is very much economical. That depends upon the cost of the substructure and superstructure. Whenever a graph is plotted, if this cost of the substructure is equal to the cost of the superstructure, then that span will be most economical. Then discover depth. We need to know the depth of the depth which is produced by the scouring action of water. So whenever there is the water current and there will be more of whenever there is an increase in the water current there will be more of scouring action. So we need to find out the depth of the scour below the high flood level because it is very much important. The scour depth is very important because it is used for the determination of the depth of the foundation, how deep we need to provide the foundation. Then the vertical clearance, that is above the high flood level where the deck slab should be provided. So we can't provide a deck slab, the slab can't be provided just at the high flood level because there will be the water will be because of the wavy action, because of the water current, the water forces, there should be some amount of freeboard that will be left between the water and the superstructure. So this minimum vertical clearance of 5 meters should ensure over the full width of the roadway. So whatever the road you are going to provide along the bridge, along the entire width of the roadway, we should ensure a minimum vertical clearance. So this is measured from the highest point of the carriageway and allowance for any future raising of payment should also be made. The traffic projection. So in the cities and all, whenever we are going for multi-level bridges, that is for the traffic, easy movement of the traffic, we have to analyze the traffic. For the bridge design, the traffic projection defines the amount of traffic passing through the bridge. So this helps in estimating the type of loading, the cases in emergencies, the amount of traffic increases so that a sufficient space is provided for the vehicles to go through the bridge without facing any problems. Then what type of bridge I am going to select depends upon the geometric condition of the site. What type of road alignment, the design plan, the high water level, then the traffic capacity, structural stability, foundation conditions, what are the locally available materials, the equipments, the knowledge of the contractor, the clearance required above the road level. So these are some of the aspects that should be considered while selecting the bridge type. So coming to what is a deck slab bridge. So a bridge with an upper horizontal beam that carries the roadway or the railway is known as the deck of the bridge. In deck slab bridges, the deck itself is the structural frame, or the entire deck is thin beam acting entirely as one primary member. So these types are used where the depth of the structure is critical factor. So a slab deck is one where the deck is analyzed as a plate. If the slab has the different stiffness in two directions right angle to each other, the bridge is analyzed as orthotropic deck and the bridge is known as the deck slab bridge. So this is a example of your deck slab bridge. And the loading classification that will be considered is IRC class AA loading or 70R loading. We have class A loading and class B loading. Normally class B loading is adopted for temporary structures only. And these are the different loads and forces and stresses that will be considered. Dead loads, live loads, snow loads, impact loads, earth pressure, vehicular collision, wind loads, impact due to floating bodies, water current, centrifugal force, surcharge due to live load, buoyancy effect, temperature effects, deformation effects, secondary forces, seismic forces, wave effect and grade